Sleigh bells ring, are you listening? In the lane, snow is glistening, a beautiful sight, we're happy tonight, pretty sure we're never going back to school. What's up, DSA Calculus? It's Mr. Maltzby here with the second snow day video lesson. Before we get started in our assignment today, I just want to point out, as you can tell, I have probably not gone anywhere for the last 3 or 4 days. So before we get into the math, let's take a quick look at what I've been doing with my free time.
Sick of seeing you cry, of wasting all your time.
I can't believe they all went in the cup. Just get up there and knock some dust off my
Space, the final frontier. These are the voyages of the Starship Enterprise. Red alert, Captain. Romulans decloaking.
Let's knock some dust off my other bowling trophy. That's what a derivative does. Get the dust off of this bowling trophy. I'll cook your steak, I'll cook your steak, Alejandro. Don't call my name, don't call my name, cilantro. Gotta pick between my two favorite movies.
Like a picture in your purse.
Down in the mud here under the sea. Are you?
How great was that? I bet you didn't think you were going to get to see all those crazy adventures when you clicked on the video. I thought you think it's just going to be boring math. Which it is totally going to be from here on out. So here's what I'd like you to do. If you have not done the thing called Monday warm-up, do the thing called Monday warm-up. Or if you haven't checked your answers yet, just go ahead and check your answers. You can hit pause on the video. I'll make a funny face. All right, hopefully you did hit pause and you looked through all this work. I'm going to go bye-bye. And from here on out, we're just going to be focused on the math at hand. So the main thing we're going to do today is just go through the answers to the other assignment you were assigned. Talk a little bit about the idea of area above the x-axis and area below. And then also talk a little bit more about what the integral symbol means in some very specific scenarios. What we call our particle motion or our moving object scenarios. So the warm-up was just practice doing a left Riemann sum. And once again, and I didn't talk about this yesterday, rectangle sums are when we use the same delta x. Riemann is just our word for these kind of uneven widths. So 10, 20, 15, 15. We wouldn't call that an LRAM or an RRAM. We would call it a left Riemann sum. And we'll talk more about that when I see you in class. So anyhow, I worked out the integral's value approximately, doing 10 times 60, 20 times 80, etc. Here's one thing I want to talk about. A does not ask you for the meaning of the integral, because the meaning is actually pretty awkward. If you find the area for a graph of minutes and people, or skiers and people, what you get are skiers' minutes. Like the variables don't multiply together in a pretty way. So the units for A were skiers times minutes, and that wasn't part of your answer, but I just want to point that out. Because B, which is a preview of a topic we'll talk about in a few days called average value, does have some units that make sense. We're told to just take our value from part A and throw a 1 over 60 in the front. So we're going to multiply it by 1/60th. And what that does is it drops that value down to 67.917. And this is what we'll talk about soon, that this is what's called average value. If you look at this table, sometimes there's 60 people, sometimes there's 80, sometimes there's 55, sometimes there's 50. What we've calculated is that on average, kind of at any particular random time, the average amount is 67.917. And you can tell if we take our measurement from A, which was skiers' minutes, and we divide by 60, and 60 is a measurement of minutes, right? 60 minutes. If we take our skiers' minutes and divide by 60 minutes, then our units drop back to something more meaningful, which is skiers. So anyhow, that's the deal with that. If you have not done question 2, I would like you to actually go through and do this on your calculator and double check that your values are the same as mine. And I know this is kind of boring, but in that space that says notes, press pause on the video and just copy down what's at the bottom of the page. There's a typo. This should say area is a positive number. Area is always a positive amount. However, certain sections area decreases the total value of the definite integral. The value of a definite integral is the area above the x-axis minus the area bounded below the x-axis. So just jot that down. Remember I said area is a positive number. So let's actually get into our lesson for the day. So on our next screen, we have something y'all did not have as part of your assignment, but it is a graph of y equals sine x plus 1/2. I graphed it on the domain from negative 5 pi over 6 all the way up to 11 pi over 6. And what I've added to the picture are the areas for 3 sections. This section on this domain has an area of 0.685 units, square units. This kind of area trapped right here is 3.826 square units. And then once again, we have another one of these little sections, so it has the same area. It's 0.685 units squared. What I want you to do is just take a minute and process how these different integral totals work. The first integral is from negative pi to 7 pi over 6, so its value is just this area. However, the next one is from 7 pi over 6 to 11 pi over 6. It's from here to here. And since this area is below the x-axis, this area is positive. But the integral's value, what we do is we subtract from the total. So it's really just 0 minus this. It's that amount. From negative pi over 6 to 11 pi over 6. So from here all the way to the end, we have 2 sections. We have this section, which will add to our total, so we treat it as a positive amount. And then we have this section's area, which will subtract from our total. So we're going to add a negative amount. So I want to reinforce this. This is a positive amount of area. But in terms of its contribution to the integral value, you subtract that amount, or you would add a negative amount. And then, of course, the last one is all 3 sections put together. The integral from negative pi over 6 all the way to 11 pi over 6. You would count this as negative. You would count this as positive, you would count this as negative, and that's kind of how you would work that out. So on the next screen, I'm going to ask you to do a couple problems. I'm going to ask you to pause the video and work through a couple of questions. And you're really just basically looking to break down a graph into area bounded above and treat it as a positive number, and then the area bounded below and treat it as a negative number. Okay, let's see how you do. And on the next, in a few seconds, I'm going to show the answers. So now's a chance to hit pause, read these questions. I know it feels like the video is going fast. Hit pause, read the questions, and when you unpause, you're going to see the answers. Okay, I'm going to bring up the answers in 3, 2, 1. So for the first section, I just worked out. I didn't even worry about area of a trapezoid. I just turned it into squares and rectangles and triangles. I have an area of -1, or have an area of 1, 2, 4, and 1. And then this area of 2 will count as negative. So I added these together, it made 8, subtracted this, makes 6 as a total. And then what I did for this one is I kind of looked at each integral, said, okay, 0 to k is a positive amount. 0 to j would also be a positive amount, but it's not quite as big as 0 to k. So I said a is positive and b is positive, and a is greater than b. Then I looked at c and d. 0 to m has a little bit of area that counts as plus and a lot of area that counts as minus. So C is going to be a negative number. D is just K to M. So it's basically the same amount of negative, but none of the positive. So it's overall going to be kind of even more negative. So D is less than C. So D is kind of the greatest negative amount, followed by C, which is kind of barely negative, B, which is that little bit of positive, and then A, which is kind of all of the positive with none of the negative. All right, I hope you did well. By the way, this is just a question off last year's quiz. And this is a question off an exam from a few years ago. And really, it's just, do you know that symbol means area? And also, do you know the difference between the area you add and the area you subtract? Doesn't really require a lot of kind of hard number crunching. What we're going to do on the next is just kind of bring up the other part of the... Sorry, my wheel is spinning out a little bit. So this is kind of the remainder of the classwork. I just want you to check your work and read over this lingo. Honestly, I would hit pause, complete the assignment, check your work, and the main thing I'm going to ask you to do is kind of take the notes that are on the next screen, which is the last screen. All right. And then here are our notes. If you feel like, hey, we just blew by that section, go back to the video, hit pause, read my answers, reread your questions and the work that you've done. And these are our notes. And what we want to just do is talk about the meaning of a few specific integrals. When you integrate velocity, it specifically refers to total change in position. So the mouse's total change in position was the area above before 4 seconds minus the area below from 4 seconds to 7 seconds. That was his change in position. His total distance was both of those areas added together. So absolute value, everything counts as positive. So the mouse's total distance was 12.28. So that was the integral from A to B of the absolute value of the velocity. And then something that wasn't on there is a quick little definition. That total change in velocity is what you get when you integrate acceleration. Integrating acceleration and working out the units for the area of an acceleration graph we haven't done yet, but you can see below if acceleration was miles per hour squared and then your time is your hours. If you multiply those units out, an hour cancels from each term, and what you're left with is miles per hour. So we go to our cookie cutter sentence. It's the total change in X units times Y units from A to B. And what I've just done is I've crossed out total change in miles per hour and called that total change in velocity. After all, that's what velocity is. It is a measurement of miles per hour, right? Just like when you drive your car, your speed, that is your miles per hour. So out goes the word miles per hour, in goes the word velocity measured in miles per hour. Thank you for making it to the end of the video. I don't think I'm going to put these on the pop quiz just because I'm worried about students not watching the video but having to take the pop quiz. But anyhow, I would say within a day or two of when we get back, knowing that this symbol is equivalent to this statement for all three of these is a big deal. Okay, I hope, make sure you did all of the work. Make sure you checked all of the work. And anywhere that we had notes in some of those assignments, go back to each video and kind of fill in the appropriate notes. Also, if you kind of skipped over any of the extra questions asked in the video, please do those. Let me see if I can bring my webcam back up. All right, I'm going to go now. This is the last planned assignment. If we are gone Wednesday, there will be no more assignments. If we, for some reason, are out all week, which we are not going to be because the temperature is rising, the sun is shining. But if we're out for 4 or 5 days, I'm going to put another assignment online. But anyhow, there were 2 videos that I hope you watched, and I hope you kind of did all the work that was asked of you. If we miss Wednesday, just relax. Make sure you're rock solid on everything we've done. If we miss Thursday, there will be one more assignment. All right. Say goodbye, Mr. Maltzby. Goodbye, class.